It is time. Video number 62. We're going to talk about sample spaces and theoretical probabilities.
Yes.
This fits exactly what we're doing in class.
Okay, the sample space is the set of all possible outcomes, okay, of a random phenomenon. So remember the random, what? Oh, I thought you were going to say something. Sorry.
No, so this looks like the one in class. You said
Yes.
we have the first die is red.
Right.
Actually, I kind of like this. So this shows all the probability, all the possibilities when you roll 2 dice.
Mm-hmm. Right. So there's our sample space of all 36 options. Okay.
All right. Now, when you have the sample space, that helps answer probability questions.
Yes.
So it's not always going to be available, so we're going to need some other things.
Mm-hmm.
The laws of probability soon. But when we can, sample space is great.
Right. But our theoretical probability, whenever we're dealing with that, it's going to be out of our 36 total outcomes, out of our sample space.
Right.
Okay, that's our denominator. So here we want the probability of a sum equal to 10. Well, 6 and 4, that's the easy one. 6, where's the other 6 and 4? There it is. Okay.
Those two.
5 and
then
5.
5 and 5.
Yep.
So
right here,
those
that
three.
nice little diagonal.
Right. So 3 out of 36, which we can at least reduce to 1 out of 12.
Yes.
All right. So 1/12 of the possibilities end up adding to a 10. So if we do this in the long run, 1/12 of the time, we'd expect to roll a 10.
Mm-hmm.
Okay. All right. Next.
All right, so probably rolling exactly one of the dice is a 1.
All right. So let's find all of those.
Well,
Now this is an event. An event is a collection of outcomes.
right.
And so if any of these die rolls he's circling occurs, we'd say that the event that we got exactly 1/1 occurred.
Oops, I don't know. Oh yeah, hang on.
Yeah, go backwards there.
Yeah, there we go. I'm like, the column's supposed to be there.
All
Okay,
right, so
so the reason I didn't circle the top one is because we just want 1 dice. That would be 2.
Yeah, that one doesn't count.
Yes.
Okay. So we have how many?
5 and 5 is 10.
All right.
So we'd have 10 out of our sample space of 36, which we can at least simplify down to be
5 out of 18.
5 out of 18.
A little bit less than a third.
Yes.
Okay, so a little bit less than a third of the time.
Mm-hmm.
So that's the theoretical probability. So if you went and took 2 dice and did it, and count how many times you got exactly 1/1, eventually it'll approach 5
Right.
18ths.
It's that fun law of large numbers we
True.
kind of briefly talked about.
Okay, different question. Probability of rolling doubles.
Doubles.
How many doubles are there?
Well, it'd be 6.
Double 1s, 2s, 3s, 4s, 5s, 6s.
All
Good.
this column right here.
Okay,
6 out of 36, or 1/6.
very good. Okay, next one.
Mm-hmm.
7 or 11.
7 or 11. Okay, so
So-
the 7 column, that's all these guys.
So Mr. Lewis is going to make a video about how to shoot craps and win at craps.
I don't know if videos would be good, but maybe it in class.
Is this high school or college? You got some experience at this?
Oh,
Both?
I learned after college.
Oh, okay. Oh, grad school?
All right, so there's 6 ways you can get a 7. There's only 2 ways, though, you can get 11. So here is 8 out of 36, or 4 out of 18, or
2 nines.
2 nines.
All right, let's switch to cards. So next one. Okay, now, if
That's
you're
a
not
nice
familiar with cards, sometimes people haven't played cards too much. Remember, there are 4 suits. The top one are clubs, the second row are the hearts, third row is spades, and the bottom row is diamonds. Okay, and then each suit has ace through a king. Okay, so the face cards obviously are the ones with a jack, queen, or king.
Right.
So the ones with a face on them. That makes sense.
Mhm.
All right, so if you're dealt 1 card, so we got 1 card randomly picked from there, that's the sample space of what could happen. That's the whole deck.
Right,
So if we're dealt 1 card, those are the possible outcomes.
and there are 52 cards in that deck.
Right. 4 suits of 13. So
Yes.
how many face cards?
There are 12.
So 12 out of 52. That's a chance of getting a jack, queen, or a king.
Mhm.
And that will reduce to both divisible by 4.
4, this would be 3/13.
Yeah. Probability of getting a red ace. How many red aces are there?
There are 2.
Yeah, there's the diamonds and the hearts. So 2 out of 52.
Or 1/26.
Yeah, so 1/26 of the time you would expect to get a red ace.
Okay.
And a spade between 2 and 10. You want to circle that event?
Yeah, that'd be all these guys.
So
right
that's the
here.
event we're talking about. If we get any card in there, we say that event occurred. So the event of getting a spade between 2 and 10 probably is 9 out of
52.
good. All
Got
right,
it.
easy enough.
Okay.
Right, now, this time, we have to do a little work here. We have 4 students, Sandra, Tom, Fred, and Ralph. So Sandra's a female. Tom, Fred, and Ralph, they're all guys. And we're going to randomly pick 2 of them to do a geometry project.
Mm-hmm.
So the question is, if we randomly pick 2 of them, what's the probability that Sandra is one of them, the girl is one of them? So first thing we want to do is work out the sample space.
Yep.
So we could have Sandra and Tom, ST, Sandra and Fred, Sandra and Ralph. Okay, those are all the possible groups with Sandra. Then we could have Tom and Fred. We have Tom and Ralph. And then there's one more possibility.
Tom and Sandra.
No, we have that one. Fred and Ralph.
Oh, right.
Yeah.
I thought you meant
Just
overall.
right here,
I'm sorry.
actually, order
I thought you
doesn't-
meant with Tom.
Yeah.
I was like, wait a minute.
Actually, order doesn't matter. So this which 2 people,
Right.
we're keeping track of the different combinations of 2 people. So this is the sample space. These are all the different pairs of people.
Yes.
So we see that there's 6 different pairs of students.
Mm-hmm.
Okay, let's answer the question. What is the probability that Sandra will be one of the students selected? So we're going to randomly pick one of these 6 pairs of people. We want to know the probability that Sandra is one of them.
So, be 1/2.
So 50-50 chance.
Mhm.
Okay. All right. Next, we're going to do something that mathematicians like to do. They like to generalize something. So this time, let's add another person. We're going to add another guy, Bob. So we got 1 female, Sandra. We have Tom, Fred, Ralph, and Bob. And ultimately, we want to ask the same question.
Right.
If we pick 2 randomly to be in a group, what's the probability that Sandra gets picked? So we got Sandra and Tom, Sandra and Fred, Sandra and Ralph, Sandra and Bob. Now we have Tom and Fred, Tom, Ralph, Tom and
Bob.
Fred and Ralph, Fred and Bob, and Ralph and Bob.
R.
So this time, how many pairs of people?
There are 10.
10, okay. And how many have Sandra?
4.
So 4 out of 10. It's a little bit less than 50-50, which was last time, which is 2/5 chance. But
40%.
it shouldn't surprise us that if we had more males, then it's less likely that Sandra will be one of the pairs. So a mathematician would ask, what if you had 1 girl and 1,000 guys? We won't go there though.
Right.
Enough of that. But there'll be some examples in class where we have to figure out the sample space, figure out the possibilities.
Mm-hmm.
All right. So Louis, it is journal time.
Yes, it is.
So much like the 6-sided dice, we have 2 4-sided dice that we're going to roll. You want to explain what that diagram's saying there?
So the diagram here, this is your sample space for the 4-sided dice. Okay, all the way from 1-1 to 4-4. Okay, so since we have 2 4-sided dice, there's going to be 16 total possibilities that we're going to do. Okay, so then for each one of these, answer the question to deal with the sample space. So what's the probability that at least one of the dice is a 1? What's the probability that exactly one of the dice is a 1? Find if the numbers on the dice are added, what's the probability of getting a 6? Find the probability of getting numbers that add to 7.
Mm-hmm.
And then finally find the probability that neither of the dice is a 4.
Wow. All can be done with that diagram.
Yes, I can.
All right. Good luck. We'll see.